Binomial Expansion Introduction. Just going to run through the basics of the binomial expansion, and this is going to be for those people without aid to a calculator, so we want to keep it fairly simple. And to start with, I'm just going to look at a very simple double bracket expansion. So I've got 1 plus x all squared, which is 1 plus x times 1 plus x. And we should be able to work out that that is 1 times 1, 1 times x, 1 times x. So I get 2x and x times x, which is x squared. Now, if it starts to get more complicated, so I increase the power, 1 plus x cubed, I will have this bracket, which is 1 plus x times 1 plus x, so that's the squared, and then I have to times by another 1 plus x. So I end up with 1 times 1, 2x times 1, which is 2x, and that will go with the 1 times the x, so that will be 3x. And then I've got x squared times 1, and the x times 2x, that makes 3x squared. And then I've got x squared times x, which is x cubed. Now, the binomial expansion allows you to work out these values of the expansion, so the next one, 1 plus x to the power of 4, very quickly. This, you can see the pattern here, it goes 1x, x squared, x cubed, and then these numbers 1, 3, 3, and what would be 1 there, those numbers come from something called Pascal's triangle. They are combinatorial numbers, but we don't need to worry about that because we've not got access to a calculator. If we draw Pascal's triangle out, so we start with the numbers 1 and 1, and then if we add the numbers coming down, 1 plus 1 makes, sorry, not 1 plus 1, you always go down 1 here, and then you add the 2 above to make the 1 below, so 1 plus 1 is 2, there's only a 1 above this number, so it's 1, and down the sides you always have the number 1, but as you come into the middle you've got 1 plus 2 makes 3, 2 plus 1 makes 3, so that's my 1, 3, 3, 1. 1, 2, 1 was that row, so if I want the fourth power I need to go down another row, so that goes down 1, 1 and 3 makes 4, and you'll notice that this pattern 1, 2, 3, 4, so the first number is always just the number 1, the second number is always just the number of the power, and then you add the two middle ones to make 6, and then it repeats itself. It's got a line of symmetry down the middle. So to multiply this out, I wouldn't multiply it all out, I just know that I can do the 1 on its own, plus 4 lots of x, plus 6 lots of x squared, plus 4 lots of x cubed, plus 5, x to the power of 4. Okay, it's all very well and good, but what happens if it's not 1 plus x to the power of something? What happens if it's something a bit more complicated, like 3 plus x to the power of something? Let's just have a look at 3 plus x squared. 3 plus x squared is 3 plus x times by 3 plus x. So we get the 3 times the 3, which is 9. I'm actually going to write 9 though. I'm going to put 3 squared, because it'll explain what's going to happen later. And then I've got 3 times the x, and the x times the 3. So I've got 2 lots of 3x. I'm going to use a dot notation for times in this, because otherwise the x is going to get confusing. And I've got x times x, so I've got x squared. Okay, now remember our Pascal's triangle. Let's have a little slightly bigger version of it over here. On the second row it goes, the third row, which is the one we're using here, we've got 1, 2, 1. So we've got 1 lot of 3 squared, 2 lots of 3x, and 1 lot of x squared. If we go up a power, so we go 3 plus x cubed, then I've got this 3 squared plus 2 times 3x plus x squared times by 3 plus x. So now I've got 3 squared times 3, which is 3 cubed. I've got 3 squared times x, which is 3 squared x, and then I've got 2 times 3x times 3, which is 2 lots of 3 squared x. I've got 3 squared x and 2 lots of 3 squared x, which makes 3 lots of 3 squared x. And then I end up with, for my x squared term, I'm going to have x squared times by 3, which is 3x squared, and I'm going to have 2 times 3x times x, which is 2 times 3x squared. So I'm going to have 2 lots of 3x squared plus a 3x squared, so that's going to be 3 lots of 3x squared. And then the last term I've just got x squared times x, which is x cubed. Now what's happening here is, if I put an x to the 0 here and I put a 3 to the 0 there, maybe you can see that this is going 3 cubed, 3 squared, 3 to the 0, which is just 1. Then it's going x to the 0, x to the 1, x squared, x cubed. So as the 3's are coming down, the x's are going up. And in front of those we have 1 lot of 3 cubed, 3 lots of 3 squared, 3 lots of 3 squared, and again there's be 1 lot of this. And then those numbers come from the Pascal's triangle. So if I'm going to demonstrate how that works for x to the power 3 plus x to the power of 4, okay, I'm going to start by having a 3 to the power of 4, then 3 to the power of 3, then 3 to the power of 2, 3 to the power of 1, which is just 3, and 3 to the power of 0, which is nothing. And that's going to be times by x as it goes up, x to the power of 0, which is just 1, so I don't need that, x to the power of 1, which is just x, x squared, x cubed, and then x to the power of 4. And then the numbers we times those by are the numbers on the row that starts 1, 4, 6, 4, 1. So 1 times this, 4 times that, 6 times that, 4 times that, and 1 times that. And we're just adding them because it's all adding. Okay, so what that actually gives you is 1 lot of 3 cubed. 3 cubed is 81. 4 lots of 1 lot of 3 to the power of 4, which is 81. 4 lots of 3 cubed, 4 lots of 27. 4 lots of 27, 4 lots of 7 is 28, 80, 108 x. 3 squared is 9 times 6 is 54 x squared. 3 fours are 12 x cubed. And we've just got the 1 lot of x to the power of 4. So that's how we expand when the number is not a 1 in the front. Okay, so what happens if it's not just an x on its own? Let's have a look at that. I'm actually going to change to a different letter. I'm getting a bit bored of x's now. Let's try something different. So let's go 1 plus 2 lots of a. And we're going to keep it to the power of 4. Now the powers of 1 keep going up, so we go 1, start at power of 4 and just count down. 1 to the power of 4, 1 to the power of 3, 1 to the power of 2, 1 to the power of 1, 1 to the power of 0, which is just 1. So we're just going to have whatever that last term is. Let's just put a plus there for now. And then this thing, the 2a, is going to increase in powers. 2a to the power of 0 is just 1, so we ignore that. 2a to the power of 1 is just 2a. Then we're going to have that times that, and then we're going to have 2a squared, and then we're going to have 2a cubed. Oops, that needs to be outside the bracket. And then we're going to have 2a to the power of 4. And then we've got the standard numbers 1, 4, 6, 4, 1. So we've got 1 lot of that, we've got plus 4 lots of that, plus 6 lots of that, plus 4 lots of that, plus 1 lot of that. Okay, let's tidy that up a little bit, let's talk it through. 1 lot of 1 to the power of 4 is just 1. 4 lots of 1 to the power of 3 times 2a. 4 lots of 1 to the power of 3, well, that's 1 times 4 is 4. And then we times them by that 2 to make 8a. 6 lots of 1 squared, so 6 times 1 is 6. 2a squared is 2a times 2a, which is 4a squared. So we've got 4a squared times the 6 is 24a squared. And then we've got 4 lots of 1, which is just 4, and we've got 2a cubed. So the 2's cubed and the a's cubed, so we've got 8a cubed times by 4, 8 fours, 32a cubed. And the last one, 2a to the power of 4, well 2 to the power of 4 is going to be 16, and a to the power of 4 is just a to the power of 4, and we times that by 1. So that would be our expansion there. So all we do is the same as before, but if we've got a multiple a, we put it into the bracket. What about if that's a negative number? Minus 2a to the power of 4. Well, it would be almost identical, apart from, if we think about the 2a isn't being minus 2a, so let's just look at the first term, it's just going to be the same, it's just going to be 1. The second term, you're going to have minus 2a in there, so you're going to have 4 times 1 cubed times minus 2a. So that's going to give us a negative value. I'll put a plus in there when I shouldn't have done. It's going to give us a negative value. So it's going to be exactly the same, except for it's going to be negative. And then when we square minus 2a, that becomes positive. So that stays the same, plus 24a squared. And then when we cube it, we get a negative, so we get minus 32a cubed. And then we do the power of 4, we get the positive again. So the minus sign just makes it oscillate between positive, negative, positive, negative, positive, negative, depending on the power that you're using. So the first one is the positive, then it becomes negative, then positive, and so on. Okay, just going to finish off with what sometimes you're asked to do, which is you're not always asked to write out the whole expansion. So sometimes if the powers are quite big, you only have to write the first few terms. So let's just do one with much bigger numbers. So let's try 2 plus 3x to the power of 6. Okay, so our Pascal's triangle, let's start from the beginning again. Well, let's see if you can do Pascal's triangle. Think about what it is before I write it down. So we've got 1, 1, 1, 1, 2, 1, because 1 plus 1 is 2, 1, 1 and 2 makes 3, 2 and 1 makes 3, 1, 1, 4, 1, 4, and it goes on the outside, just 1 and then the numbers increase. 3 and 3 is 6, 4 and 4 is 10, 6 and 4 is, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and we've got 1 on this side, and 1 on the 6, then we've got 15, 20, 15. So we're going to look for the power of 6, we want this row here. And if we just want the first 2, 3 terms, so I want the power of x, where x is equal to 0, it means there's no x. I want the x to the 1 term, and maybe the x squared term. Let's start with the x to the 0 term, so the first term. So we start with a 2, and we start with 2 to the power of 6. Remember, the 2's powers go down, the 3x powers come up. And we've got 3x to the power of 0, which is just 1, and we're timesing that by 1, so we're just left with 2 to the power of 6 as our first term. Our second term is going to be 6 lots of 2 to the power of, the powers go down to 5, times 1 power of 3x, so times 3x. And then the x squared term, I'm going to have 15 as my third term, times 2 to the power of 4, because the 2's are coming down, times 3x, and that's going to be squared, so I'm squaring the 3x. So if I just want the first 3 terms up to x squared, these are the ones I'm looking at. So 2 to the power of 6, 2 cubed is 8, 4 is 16, 5 is going to be 32, 6 is going to be 64, so that's 64. Then we've got 2 to the power of 5, which is 32, 32 times 6, 32 times 6 is going to be 180, 192, and times 3x, I'll work that out in a second. And then we've got 2 to the power of 4, which is 16 times by 15, so if I do 2 15s are 30 and do 8 30s, 240 times 3x all squared, so 3 squared is 9 and x squared, so I need to work out these two terms to get the final finish. So 192 times 3 6, 27, carry 2, 355, 76, x. We've got 64 plus 576x, and I've got 240 times 9. It's going to be 0, 6, carry 3, 18 is 21. So 2160 x squared. There are more terms, and it goes x cubed, x to the power 4, x to the power 5, x to the power 6. X to the power 6 was just going to be 3 to the power 6, x to the power 6. But quite often you're only asked for the first 3 terms up to x squared, and sometimes only up to the x. So that's how you would do that. And to finish with, I'd just like to say good luck to Holly, Natalie, Callum and Alice, who go into maths competition, and this video was created so that they could revise for one of the rounds. If you make sure you focus on the first 2 slides, and make sure somebody learns the Pascal's triangle before you get there. Good luck, and I'll see you when you get back.